In this video, we're going to talk more about polynomial functions and their key characteristics. So if we look at number 1, I see a function that has a negative coefficient as well as an even degree. So what that's telling me is if it's an even degree but a negative leading coefficient, that it's going to open down like this. Or it could be like this, could be like that. But again, both ends are going to point down. So that means in terms of my limit, as x goes to the right, it's going to go towards negative infinity, and as it goes to the left, it's also going to go towards negative infinity. The maximum number of x-intercepts is the same as the degree, so it'd be 6. The minimum number of x-intercepts, well, since it's an even function, it doesn't have to hit the x-axis at all, so that could be as low as 0. If it's an odd function, if it was an odd degree, the answer to this one would be 1. What is the most points of inflections? Remember, points of inflection at most is always 2 less than the degree, so it'd have at most 4 points of inflection. And our extrema is always at most 1 less degree, so it'd be at most 5, or it could be 3, or it could be 1. So because the degree is even, the number of inflection points will always be odd. And then vice versa. If it was a degree odd, the number of inflection points will always be even. All right, let's look at this graph. So again, I can see that both my ends are pointing down. Since they're pointing the same direction, I know that this is a degree, is an even function. It's also pointing down, so I know that my leading coefficient is negative. The degree is even and has at least a degree of what? So if I look at my extrema, I have 1, 2, 3 extrema. So my degree will always be 1 more than my extrema, so it'll be at least a 4th degree, meaning it would have at least 2 inflection points here and here. Oh, it says to circle them. Here and here. All right, we're going to talk about multiplicity. So zeros of odd and even multiplicity. So it's the number of times a 0 repeats. So let me give you an example. So let's say I have a function x minus 3 squared, and then x plus 2 to the 3rd. So this guy, his multiplicity would be 1 because it's a first degree, it repeats once. This guy's multiplicity would be 2, again because of this second degree. And this last guy, as you can guess, his multiplicity would be 3 because of the 3. Something else we could talk about is also the degree, or the number. So this guy's x-intercept would be 0. This guy's x-intercept would be positive 3. This guy's x-intercept would be negative 2. So we're also going to talk about what multiplicity means and how that shapes our graph. So if a polynomial function has odd multiplicity, then the graph crosses the x-axis at that value. So if the multiplicity is odd, so again, if the multiplicity is 1, 3, 5, that means it's going to go through the axis at that number. Versus if it's even, then the graph is tangent to the x-axis at that point, meaning if the multiplicity is 2, 4, 6, etc., instead of going through, so let me change this color maybe. So this goes through the axes. This is going to like touch the axes at that point, not go through it, be tangent to it. It also has a note here that if a 0 is even and greater than 2 or odd and greater than 1, then the graph tends to flatten out at the zeros. So if it's a multiplicity of 1, it's going to go straight through. If it's a multiplicity of 3, it's gonna kind of flatten out at that point where it goes through. Similarly, if it's a multiplicity of 2 or a multiplicity of 4, so 2, it's just gonna be boop, directly tangent. If it's a 4, it's gonna be more like boop and kind of more flatten out at that point. All right, so let's put this all together. Let's sketch this graph. So using this equation, let's talk about everything we know. So I have a degree of 1, a degree of 2, and a degree of 1. So 1 plus 2 plus 1 means that my total degree of this polynomial is 4. I know that my zeros are at -2, it's always going to be the opposite, +1, and +3. So -2, +1, +3. I also know, because my leading coefficient is negative, that my graph is going to open down. So that means my arrows at the ends should be pointing down. If I look at -2 and 3, since those are odd, I know that my graph is going to go through those points, versus at 1, since my multiplicity is even, I know that my graph is going to just touch at that point. Let's see, what else can I figure out? The y-intercept I can figure out, because if I plug in 0, I would have -2, and this would be -1 squared, so 1 times -3 would give me +6, so my y-intercept would be at +6. So I should make sure it goes through that point. Again, with this opening down idea, that means that as my limit of x approaches infinity, the function is going to -infinity, and the limit as x approaches -infinity means the function's also going negative. So it's going to go negative in both cases. So that means at my ends here, it's going to be pointing down, which is good because it's going to go through at 2 and 3, -2 and 3. So through, touch, down, and back through. So my graph would look something like this. All right, let's do the same thing with this one. So x to the 4th, and then x to the 3rd, and then x to the 2nd. So 4 plus 3 plus 2 means my degree is 9. I also can see that I have 3 x-intercepts. I have an x-intercept at x equals 0, x equals 2, and x equals -1. So 0, 2, -1. At 0, it is even, so I know that it's going to just touch at that point. At 2, it's going to go through because it's odd, and at -1, it's also just going to touch. Now my leading coefficient is positive, and this is an odd function, so I know it's going to be increasing on the right and decreasing on the left. So that means my limit as x goes right, my function will be positive. The limit as x goes left, my function will be negative. So that means at this point it's got to go down, and at this end it's got to go up. And this point it's going to bounce, and this point it's also going to bounce. So based on that, we're going to bounce, go down some amount, and then go up and through. I'll erase this little part. But it would look something like that in order to meet all those qualifications. All right, 5 says, sketch a 5th degree polynomial with a negative leading coefficient, 3 x-intercepts, and the maximum number of extrema. Label the inflection points A, B, and C. All right, so if I have a degree of 5, the maximum number of extrema would be 4. If I have a negative leading coefficient, that means I'm going to be going positive on the left and negative on the right. So that means my limit as x goes right is going to be negative, and my limit as x goes left is actually going to be positive. And I need 3 x-intercepts. So otherwise it's pretty open. There's lots of different ways, but if I need 4 extrema, so maybe 1, 2, okay, so I can't cross again until I can make that third, so maybe something like this. So 1, 2, 3 x-intercepts, 1, 2, 3, 4 extrema. I am going positive on the left and negative on the right, so this works. I have inflection points at pretty much here, A, B, and C. So this is just one example. There's lots of different examples that would meet all these criteria, but this is just one of them. All right, use the table to sketch the graph below for the following polynomial function. So it's saying from negative infinity to negative 4, the value of the function is negative. Well, negative means it's below the x-axis. 0 would mean it's on the x-axis. Positive would mean it's above the x-axis. So from negative infinity to negative 4, it's below. And then once I hit negative 4, it's on. And then it's going to go positive till I get to negative 1. So let's just sketch that part. So negative, positive between negative 4 and 1. Then it switches to negative. So it's going to go through there until I hit 2. But then after 2, it actually stays negative, but it does hit at 2. So that's actually going to look more something like bouncing off 2 and then going down. Say 2 is more like right there. So it starts negative and ends negative. So let's just double check that I did this right. So between negative infinity and negative 4, it's negative. At negative 4, it's 0. Between negative 1, or negative 4 and negative 1, it's positive. Between negative 1 and 2, it's negative. At 2, it's 0. And then from 2 to infinity, it's negative, which I would agree. So remember that these are the intervals for x. When it's talking about negative infinity and infinity, it's talking about the left and the right side of the graph. So let's answer some questions about the graph we sketched now. It says, what are the real zeros for f of x? So I would say negative 4, negative 1, and 2. What is the least possible degree? Well, since I have 3 extrema, that means the lowest possible degree would be 4. Because my extrema equals 3. Write a possible equation. Ooh, okay. So I know that because it goes through 4 and 1, negative 4 and 1, so I'm going to have x plus 4, x plus 1, because those will give me x-intercepts of negative 4 and negative 1. I'm also going to have an x minus 2, but since this one doesn't go through 2, I know it has to have an even power, so I'm going to make that squared. All right, so 1 power, 1 power, 2 power leads me to 4 powers. So this is what my equation could possibly look like. Oh, I forgot one thing. Because it's opening down, the leading coefficient had to be negative. So that would have to be in front. Make sure you don't forget your function notation. F of x would equal the negative version of each of those x-intercepts. All right, given this equation, we're going to answer true or false. So it says determine which statement is true or false. The graph of h has a local extrema at 1 and 0. So at 1, it does bounce off 1 because it has even, so that's true. And at 0, it would also bounce off because it's even, so I would say this is true. Saying as x goes left, the function's going to go positive. Okay, well, what's the degree? 2 plus 5 plus 4 plus 1. So it's a 12th degree, meaning that both my arrows have to go the same way. If the leading coefficient is negative, that means even's going to both go down. So that means as I go to the left, this would actually be negative, so this is false. The values of h change from negative to positive or positive to negative only at -3. I would disagree with that because they're also going to change from negative to positive at 6 because at 6 it should go through the x-axis. So false because it would also occur at 6. The graph of h of x has 6 local extrema. Well, that's not possible. So since the degree is 12, that means the extrema has to be odd. So this is not possible.